Black holes are mysterious and powerful objects scattered throughout our galaxy. Objects so immense and captivating that not even light can escape their gravitational pull. Today, we embark on a journey to unravel their secrets and discover what they could mean for the future of humanity. But before we delve deeper, let's first understand what a black hole truly is. Imagine a dimension where space and time are intertwined, and gravity is not a force, but rather a curvature in space-time caused by massive objects. To visualize this, picture a trampoline with a bowling ball placed on it. The ball creates a dip, pulling smaller objects into its gravitational field. Well, black holes, with their infinite density, create an abyss in space-time that is nearly impossible to fathom. The concept of black holes dates back to 1783, but it was in 1967 that the term was coined. The father of the black hole theory, John Mitchell, proposed that these invisible objects could be detected if they had a star orbiting them. And indeed, Mitchell's prediction was confirmed in the early 1970s when astronomers observed a massive yet invisible object orbiting a blue star from 6,000 light-years away. This object, codenamed Cygnus X1, was the first identified black hole, proving that despite their invisibility, these mysterious objects could indeed be detected. The science behind black holes is truly remarkable. In our own Milky Way, there may be as many as 400 million black holes, and supermassive black holes reside at the centers of at least 2 trillion galaxies in the observable universe. Just imagine the immense power contained within these enigmatic objects and the secrets they may hold. Now let's address a burning question. Do black holes actually exist? Once considered mere theories, their existence is now undeniable. Thanks to the groundbreaking work of the Event Horizon Telescope collaboration, we now have a glimpse into what was once thought to be unseeable. The collaboration captured the first ever image of a supermassive black hole at the center of Messier M87, a galaxy 55 million light-years away. This hauntingly beautiful image revealed the black hole's shadow and its accretion disk, a swirling mass of superheated dust and gas around the event horizon. But are black holes really holes? Contrary to popular belief, black holes are not actual holes in space. They are incredibly dense objects with gravitational forces so powerful that they trap everything, including light, distorting the shape of space-time around them. The term hole is used metaphorically to describe their ability to draw things in without letting them escape. Now imagine what would happen if you fell inside a black hole. As you cross its event horizon, the darkness gives way to a strange illumination. You would witness the universe beyond, observing the light from galaxies streaming in and witnessing the effects of exploding stars over eons. However, the intense gravity would stretch, crush, and break you into pieces as you approach the singularity, the infinitely small point at the center of the black hole. Eventually, your atoms would be torn apart and scattered across the singularity, leaving nothing behind but empty space. So what really is the singularity? This mysterious phenomenon lies at the heart of a black hole, where matter is compressed to an infinitesimally small point beyond our conventional understanding of time and space. While scientists believe it must exist, they are still uncertain about its true nature and origin. Some theories propose that it could be an alternative state of matter or energy, but there are other theories at play here too. Is the concept of the singularity false? According to many scientists, the notion of the singularity could potentially be an inaccurate idea. Instead, they propose an intriguing theoretical concept known as a Planck star, which challenges the notion that matter within black holes becomes infinitely compressed into a minuscule point. This concept is derived from the theory of loop quantum gravity. Advocates of the Planck star theory suggest that space and time are composed of tiny discrete units at an incredibly minute scale. This granularity and quantization give rise to the idea that our universe possesses a granular nature. Proponents argue that the discrete nature of space-time offers two significant advantages, the first being a more natural explanation for gravity. Traditionally, black holes were believed to be infinite points of infinite density, crushing everything that ventured too close. But according to the proponents of the Planck star, matter collapsing under the immense weight of a dying star does not become infinitely small. Instead, it collides with these tiny space-time chunks, creating a ball of matter that exists beyond the singularity. So could it be that black holes are just temporary blips in the grand scheme of things? Could they collapse in on themselves, or is there more to the story? Black holes, those mysterious and captivating objects in the universe, have a pivotal role in shaping galaxies. Their immense size and powerful gravitational pull make them fascinating subjects of study. But what truly sets them apart is their event horizon, the point of no return. The size of a black hole's event horizon is directly connected to its mass. The larger the black hole, the bigger its event horizon. While black holes lose mass over time due to Hawking radiation, they do not vanish completely for millions or even billions of years. Even as their event horizons shrink, the interior of the black hole remains infinitely dense and incapable of further collapse. In this peculiar realm, black holes can continue to exist across time, swallowing everything in their path, and yet carrying the secrets of ancient times. Astronomers have made a groundbreaking discovery: 6 ancient galaxies surrounding a supermassive black hole from the early days of the universe. This finding sheds light on how these massive objects formed and grew in the cosmos's infancy. It also supports the idea that supermassive black holes can rapidly expand within vast structures filled with gas, resembling intricate cosmic spiderwebs. This revelation has sparked excitement among researchers eager to unravel the mysteries held within black holes. They are determined to understand how these cosmic giants grow so quickly within gas-rich environments. And as they venture further into the unknown, more surprises await. Recently, astronomers used powerful telescopes to observe several galaxies entangled in a gargantuan cosmic web of gas, extending more than 300 times the size of our Milky Way. This web-like structure, composed of galaxies and abundant gas, provides the fuel needed for central black holes to become supermassive giants. The first black holes are thought to have formed from the collapse of the very first stars. These early black holes had to grow rapidly to reach 1 billion solar masses within the universe's first 900 million years. But how did they acquire enough fuel to fuel their growth? This colossal web-like structure, spanning galaxies and hosting an abundance of gas, may hold the answer. It is possible that this web enabled the first black holes to thrive and expand rapidly during the early universe's formative years. While further research is required to confirm this hypothesis, the discovery of this cosmic structure presents an exciting new perspective on the formation and evolution of black holes throughout time. Now here's a thought to ponder. Are black holes always at the center of a universe? It turns out that black holes can be found anywhere within galaxies. They are not limited to the central regions. In fact, smaller black holes, known as stellar mass black holes, can exist throughout the galaxy, formed from the collapse of stars. So, if you consider the vastness of space, it becomes clear that black holes have claimed this cosmic stage as their home. But here's the mind-boggling part. It's not just the massive black holes that exist. Evidence suggests that even tiny black holes dot the universe. The space surrounding us is a playground for black holes, large and small. Now brace yourselves for a shocking revelation that could turn everything we know upside down. In 2018, a small star met a tragic fate when it ventured too close to a black hole in a galaxy 665 million light-years away from Earth. This event, known as a tidal disruption event, occurs when a star is stretched and ripped apart by the immense gravitational forces of a black hole. However, what happened next caught the attention of scientists worldwide. Nearly 3 years after this catastrophic encounter, the same black hole reawakened, ejecting material at incredible speeds, reaching up to half the speed of light and directly towards Earth. This discovery challenges our fundamental understanding of black holes. For decades, we believed that what goes into a black hole never comes back out. But this newfound phenomenon seems to be the opposite, a black hole disgorging matter that it had consumed years ago. While most tidal disruption events produce quick outflows of material, this particular event displays a slower and more sustained outflow. It suggests that there may be a delay between a black hole consuming a star and discharging excess matter. This opens up the possibility that black holes could contain matter from years past, which they may eject into the cosmos unpredictably. The consequences of this revelation are staggering. The ejected material could make its way into our atmosphere, potentially causing catastrophic events on Earth. It poses a threat that extends far beyond our imagination. How this will unfold is still unknown. We can only wait and watch as the mysteries of black holes continue to unravel before our eyes. With that said, thanks for watching, and until next time,